So in the last class we were discussing about towards the end we were discussing about logical operators. We have seen three logical operators: logical AND, logical OR and logical NOT. And these logical operators, primarily the first two, are used for taking decisions based on multiple conditions. Okay, if there is only one condition, we can simply use a relational expression like this to take a decision. If age less than 30, do something, otherwise do something else, some other action. But when the decision is to be taken using more than one condition, somehow we have to combine independent conditions: age less than 30 as well as salary greater than 25,000. Okay, so we have multiple conditions, then we connect these conditions using logical operators. So logical AND means the overall expression will be true if both individual conditions are true. All other cases logical AND will be false. So similarly we had logical OR. If one of the condition is true, the overall condition will be resulting in true, and even if both the conditions are true, overall it will be true. So we saw the logic truth table for logical AND operation. Only in one case it will be 1 or true. All other three k combinations 0 0 0 non-zero, non-zero 0, it will be 0. Then logical OR operation, any one of the operand or any one of the expression from expression 1 or 2 is true, then the final outcome will be true. Then logical NOT operator basically negates the result of a relational expression. So if x less than 5 is true, NOT of x less than 5 will be false. Okay. So these are the three relational expressions, logical operators. Then now we will move on to assignment operators. Basically we have studied assignment operator in many of our programs. Say x is equal to a plus b, or sum is equal to x plus y. Assignment operator is very similar to assignment operation in mathematics. So we use this symbol for the simple assignment operator. And as I said before, whenever there is an expression having an LHS as well as RHS, the complete RHS part, right hand side part, will be computed. Then only the final result will be assigned to the left LHS part, and the LHS will normally be a variable, because we cannot assign to a constant. I cannot assign a value to a constant. So normally the LHS will be a variable. RHS can be a constant, a variable, or an expression like this. So this is my RHS. So assignment operation, simple assignment operation. Complete RHS will be evaluated and the final result will be assigned to the LHS. That is the functionality of simple assignment operator. So this everybody knows. There are some additional assignment operators. We call them as shorthand assignment operators. Shorthand assignment operators. And these are the shorthand assignment operators, plus immediately followed by equal to, equals symbol, no space in between. Similarly, minus equals, multiplication followed by equal, division followed by equals, modulus operation followed by equal. When we are using it in an expression, it looks like this: a plus equal to 5, or a into equal to 5, a mod equal to 5. Then what does that mean? What does these things mean? I'll change this to this. This is a simple or concise form of writing this expression. B equal to b plus 5 I can write it concisely using a shorthand assignment operator. Okay, so this is equivalent to this. Now shorthand assignment operators are used when the LHS variable is appearing in RHS also. Here you can see I have an LHS variable B and the RHS expression, and the LHS variable is repeating in the RHS. How the execution will happen? Suppose B is initially having value 4. Initially, when you created the variable B, you are assigning value as 4. Then when the RHS is evaluated, B will have the value 4. So this will become 4 plus 5, and the final result, I told RHS will be evaluated completely first. Then only it will be assigned to the LHS. So it will become 4 plus 5. That means 9. 9 will be assigned as the new value of B. So the existing value of B will be overwritten by the new value, which is 4 plus 5. Now if you want to write it in a concise form, you do it using the shorthand assignment operator. Okay, clear? I can show you a set of examples here. Here I have used in the normal normal assignment operator. A is equal to A plus 1. This is the RHS part. This is the LHS part. And the LHS variable is appearing in the RHS also. So this can be written as A plus equal to 1. The effect of this as well as this will be same, except that this expression is concise. Then A is equal to A minus 1. I can write as this. A is equal to A into N plus 1. I can write it this way. A is equal to A by N plus 1. I can write it this way. A is equal to A mod B. I can write this way. This is what? Shorthand assignment operators for all the arithmetic operators. Okay. Any doubt? Now why we use? There are some advantages actually. Yeah. LHS need not be repeated in the RHS. LHS variable need not be repeated in the RHS expression. So A is equal to A plus 5. I can concisely write it as A plus equal to 5. Statement is concise. And statement is more efficient. Sometimes all these instructions or all these expressions are executed by the CPU, right? CPU has corresponding machine language level commands. Sometimes there are for some CPUs there will be a dedicated machine level command for this operation, shorthand assignment operator. So in that case, this way of expressing, and when it is executed, it will take lesser time compared to this way of doing it. Here we have two operations in fact. First, addition of these two numbers, then the result is assigned to this. Assignment is also an operation at the CPU level. So addition as well as assignment. So two machine level commands are used. One for addition, one for assignment. Now if the CPU is having a command for doing it as a single operation, or a single command for doing both operation, and if you are using shorthand assignment operator, there will be only one command or one operation taking place at the CPU level. One command. So in that case, the time taken for executing this will be slightly lesser than the time taken for executing this. Here two CPU level commands are there. Here only one command is there. But all CPUs may not support such command. If the CPU supports such commands, then it will be slightly efficient. That means time taken for executing this expression will be little bit lesser than this. So we always want our program to execute faster, our apps to work faster, our web page to YouTube video to play faster. Always we want our program to execute faster. So slight time saving is done in this operation. That is one advantage. Okay. Otherwise, the effect of both these operations are same. It is just adding 5 to the variable a and assigning the result to a itself. This also will do the same effect. Okay. That much about assignment operators and shorthand assignment operators. Now we will move to another set of interesting operators. They are called increment and decrement operators. These are unary operators. The first point is increment operator is indicated by two addition symbols, plus plus. Decrement operator is indicated by two minus symbols without any space in between. Okay. So these are unary operators because they work on single operand. There will be only one operand for these operators. Remember, addition is a binary operator. There are two operands for addition. That's why we call it as binary operator. Subtraction, division, multiplication, etc. Binary operators because two operands are there. Unary operator means there will be only one operand. There will be only one operand like this. Now, what is the action performed by this operator? This will increase the value of the input variable by 1. This will decrease the value of the input variable by 1. So, effectively, if instead of doing a is equal to a minus 1, when you want to decrease the value of a variable a by 1, instead of doing a is equal to a minus 1, you can directly do minus minus a. Minus minus a. So this expression as well as this expression will do the same task. Okay. And plus plus, the converse of that, decrement decreases the value of a variable by 1. Increment operator increases the value of the variable by 1. So a is equal to a plus 1. We can concisely write it as plus plus a. Plus plus a. Both are going to give us the same output. Okay. Probably we'll see this. I have 15 in variable x. I do this plus plus x and print the value of that and execute this. I get 16. Instead of that, if I subtract or if I use decrement operator on variable x, what will be the output? It should be 14. Value 15 is decreased by 1, so the result is going to be 14. Okay, that is what basic operation of increment and decrement operators. I add a variable value by 1. So I cannot apply a constant here because it is working for variables. So if I try to apply a decrement operator on a constant, it is not going to work. Okay. So this is the basic operation of increment functionality of decrement and increment operators. Increase the value, increment operator increase the value of a variable by 1. Decrement operator decrease the value of a variable by 1. Now there are two forms of these increment and decrement operators. Two forms. One is that you use the increment operator or decrement operator before the variable. The example here, before the variable we apply increment operator. Here before the variable we apply decrement operator. And the other one is after the variable we apply increment or decrement operator. So here I apply increment operator after the variable name. Okay. So these two ways we can use increment and decrement operators. So when we apply increment operator before the variable, we call it as pre-increment or prefix increment. Pre-increment. So the operator is applied before the variable. When we apply after the variable, we call it as postfix increment. Similarly, prefix decrement, postfix decrement. In this case, there is no much difference prefix increment plus plus v is translated as v is equal to v plus 1, or effectively same as v is equal to v plus 1. Then v plus plus also same as v is equal to v plus 1. Similarly, minus minus v is same as v equal to v minus 1. V minus minus same as v is equal to v minus 1. There is no much difference between prefix form as well as postfix form. Okay, post implies after, pre implies before. So the operator appears before the variable, the operator appears after the variable. Okay, but why, if the effect is same, what is the need? There is a subtle or a small difference, or a small but important difference between these two expressions, prefix form as well as postfix form, in certain situations. So I will demonstrate that. We have an example here. Assume that all these variables are integers. Okay, I have a variable m with a value 5, and I am assigning, I have an expression here, y is equal to plus plus m. So this is the RHS part, this is the LHS part. I told RHS will be executed first completely, then it will be assigned to the LHS part. Okay, so this can be this. Now here, if you take, this is an independent expression. There is no LHS equal to RHS format. Here also no LHS equal to RHS format. Okay, now here we have a different form. LHS we have, RHS we have. Now this will be translated as, or the equivalent statement for this is m equal to m plus 1 happens first. That means RHS is computed, value of variable is incremented by 1. That means m becomes 6, and 6 is assigned to y. So this single statement I can split and write as m is equal to m plus 1 followed by y is equal to m. Now after the execution of this, what will be the value of m and what will be the value of y? After execution of this statement, y will be 6 and m also will be 6, because here in RHS part itself, this is same as m is equal to m plus 1. So first m is incremented to 6 and the RHS value, final value of RHS is assigned to LHS. So m also becomes 6, y also becomes 6. So after the execution of this statement, y becomes 6, m also becomes 6. Okay, now we rewind to the initial situation. We are setting m is equal to 5 again and applying y is equal to m plus plus. Here I applied pre-increment, here I applied post-increment, and there is a small difference. If I expand this, or the effect of this will be expressed using two statements. First, y is equal to m is going to take place, and then m is equal to m plus 1 is going to take place. So in this, say there is a difference here. When I applied pre-increment, the translation of this m is equal to m plus 1, that means first increment operation is happening, then assignment operation is happening. That resulted in y as well as m becoming 6. Here, when you apply it in this form, LHS is equal to RHS, where RHS is m plus plus, it is effectively same as first y is equal to m is going to take place. What happens? M has the value 5, that value will be assigned to y, and then increment operation takes place. So m becomes 6. So after the execution of this, the resultant value y will be 5, m will be 6. Here you see y will be 6, y is 6, m is 6. Here y is equal to 5, m is equal to 6. So whenever increment and decrement operator appears as part of an LHS equal to RHS form, this difference is going to take place. If it was independent operation like this, we wouldn't have noticed this, or we wouldn't have noticed it. But this is explicit when we have a LHS equal to RHS form. Is it clear? Slightly tricky concept. Just go through this and let me know if you have a doubt. So that is the difference of the behavior of pre-increment and post-increment operators. Both are increment operators, but if it is applied in a pre-increment manner, it behaves like this. If it is applied in a post-increment manner, it behaves like this. Any doubt? I can demonstrate this probably. So I will use this. Z is equal to x plus x, say plus plus x, and I am going to display value of z. What will be the value of? So I am going to display both z and x. Z equal to percentage d. And displaying z as well as x. And you tell me what will be the output. Both will be 16. Z is equal to 16, x is equal to 16. What happened? First, x is incremented to 16 and the incremented value is assigned to LHS. So, x becomes 16, z also becomes 16. Now, if I apply post increment instead of this, what will be the output? First, x will be assigned to z. That means the existing value of x is used in the expression, and after that the value of x is incremented. So existing value is 15. So this is translated as z equal to 15 followed by x equal to x plus 1. Existing value of x is 15, that is utilized. So z is assigned with 15. This is followed by x is equal to x plus 1. So 15 plus 1, 16. So we should get the result 15 followed by 16. Z is 15, this is 16. That is the difference between pre-increment and post-increment. Similarly, pre-increment and pre-decrement and post-decrement. If I apply this, both should be what? 14. Okay, sorry, I did not combine. Both should be 14. First decremented, then the new value is assigned to this. Here, first assigned, the existing value is used in the expression, which is 15, and after that x is decremented by 1. So this will result in 15, 14. Z is 15, x is 14. Any doubts? Anyone else is having a doubt? Please raise your voice, unmute and ask me. We will clarify it and proceed. Okay. So some general statements, whatever we discussed so far, I will put it in plain English. Both are unary operators. These work only on variables, not on constants. Okay, not even on expressions, only on variables. Postfix used in expression. First, the value of the variable is used in the evaluation of the expression, then incremented or decremented. For postfix, whether increment or decrement, First the value is used in the evaluation of the expression, then increment or decrement happens. In case of prefix increment or decrement, first the variable is incremented or decremented, then the updated value is used in the evaluation of the expression. That's what I explained in with that m and y is equal to plus plus m, y is equal to m plus plus. Precedence and associativity of plus plus and minus minus are same as unary plus, and so this will precedence and associativity will cover sometime later. At this point of time probably we will not need this. Okay, that is about increment and decrement operators. Next we move on to another interesting operator which is known as conditional operator. So far we have learned unary operators and binary operators. Unary operators plus plus, minus minus, positive symbol plus, negative symbol minus. Any other unary operator we studied? Not operator. Logical not operator is a unary operator, because all these are unary operators because there is only one operand for these operators. Then binary operators had two operands, say addition, left variable, right variable, a plus b. A and b are two operands, so two operators. Because of that we call them as binary operators. Conditional operator is a ternary operator. Ternary operator means three operands are there. Three operands are there. So this is the only ternary operator we study in C. And the symbol is like this, a question mark followed by a colon. And the syntax is like this. You have three operands. Each of these operands can be an expression. An expression, by an expression I mean a constant or a variable or a compound expression, like this. Okay, so these are all examples of an expression in C. So the general syntax is like this. You have expression 1 or operand 1, expression 2 or operand 2, expression 3. So operand 1 and operand 2 followed by separated by question mark, then operand 2 and 3 are separated by colon. So expression 1 followed by question mark, expression 2 followed by a colon, expression 3. Now how to interpret this, or how the evaluation, or what happens when we are applying an expression in this format, or when we are applying conditional operator. The term conditional means this will be this, somehow this is going to execute in a conditional manner. Okay, so the expansion of this, in this, if you are giving a statement like this, first expression 1 will be evaluated. Typically expression 1 will be a relational expression which will result in true or false. So expression 1 is evaluated first. Now if expression 1 evaluates to non-zero value or true, non-zero value is treated as true, I already told. So if expression 1 is true, then expression 2 will be executed, but not 3. And in the other case, which is that case, if expression 1 is false, expression 2 will not be executed, expression 3 will be executed. Now this is like kind of decision maker actually. Expression 1 is the decision making process. If the decision results in true, if the decision making process or the relational expression is resulting in true, this will be executed. If it is resulting in false, this will be executed. When this is executed, this won't be executed, and when this is executed, this won't be executed. Either of them will be executed, not both. And how it is decided is based on the value of the expression 1. If it is true, this is executed. If it is false, this is executed. So we can express or an analogous expression using if-else statement in C. For this one, I can express it this way also, if expression 1, but without using conditional operator. using if and else statement in C. If expression 1, we execute this, else this. So if this is true, this is executed. If this is false, this is executed. So the whole thing I can express in one line using a conditional operator. This is without using conditional operator. Here it is with using conditional operator. Clear? We'll see an example, then it will be more clear. I have two variables, a is equal to 10, b is equal to 15. Both are integers. Assume both are integers. And I am applying conditional operator. Expression 1 is a greater than b. I can either put it in bracket or I can remove it. Both are essentially same. Okay. So expression 1, second expression 2 is x is equal to a. Third expression 3 is x is equal to b. So if this is true, this will be executed. If this is false, this will be executed. In this case, you tell me what will be executed. Based on values of a and b, a is equal to 10, b is equal to 15, whether this will be executed or this will be executed. A greater than b is my first expression. Is it true or false?
False.
10 greater than 15. A is 10, b is 15. 10 greater than 15 is false. So it is going to execute this. X is equal to b. B is 15. I am assigning it to x. So x gets the value 15. Now if it was the other case, a greater than b, a is 20, b is 15, a greater than b is 20 greater than 15 is true. In that case, x is equal to a will be executed. That means 20 will be assigned to x. Okay. Now effectively what we are doing here, we are actually finding the larger of two distinct numbers. With this expression, I am finding the larger of two distinct numbers. If the second number is larger, this will be, b is larger, this will be false. We assign larger value to x. If this is larger, this condition is true, we assign again the larger number. Here in this case, a is the larger number is assigned to x. And at any point of time, either this or this will be executed, not both at all. So in that way, this expression is getting me the larger value of a and b, larger of a and b in the variable x. Are you convinced? And I can express the same thing using an if else statement. If a greater than b, x is equal to a, else x is equal to b. So finally, x will have the larger value of a between a and b. Clear? Any question? So I can demonstrate it with an example here. So x and y are there. I want to find the larger of x and y. Okay. Normally we will be taking the input from the user. So we will not know which is larger, what user is going to enter at any point of time. So I make that as assumption. User is entering some random value as the input, and we want to find the larger of those two numbers. Okay. So what I do, x greater than y question mark. So this is my expression 1. Then expression 2, x is equal to, okay, this I can omit now. Z equal to x. If this is true, x larger value is x greater than y is true, means larger value is x. So larger value I assign to Z. Otherwise, we know that there are two distinct numbers. Y is the larger value. I assign Z equal to Y. Then finally I print the value of Z. I get a compilation error. Let's see. L value. Some issue. Let me see. Z is whether. Okay, I think this way of repeating the variable in the right hand side is not allowed in this compiler. So rather we'll use this way. Okay. So expression, then x. If x greater than y, then the expression executed will be x. Otherwise, the expression executed will be y. Okay. Now, if x is greater than y, this is the expression that is going to execute, and the resultant value will be assigned to z. So x is having the value 15, that will be assigned, but this is false now. Y is actually x greater than y is false, so this is not going to execute, this is going to execute. So y is equal to 20, 20 will be assigned to the LHS. Okay, so if I execute this, I will get the value z is equal to 20, the larger of 2. Suppose this is larger, I don't change anything, I will compile and execute again, z is equal to 30. Okay, so let me see, this is permitted, yeah. So there previously I was getting an error because I was using the variable z in the LHS as well as RHS, but this is working, this is not working. Okay, okay, yeah, this is fine. If I have an LHS, then there is no problem. If I don't have an LHS, there is an issue. Even okay, some strange issue, so we will not worry about that. Okay, so instead of putting a z is equal to x there, we will put z is equal to x here, z here, z is equal to x greater than y. If it is true, this will be assigned to z. If it is false, this will be assigned. So in this case, x greater than y is true because 30 and 20. So in that case, z will be assigned to the LHS. That means the larger of 2 is assigned to the LHS. When this is larger, naturally this will become false. Then Y will be assigned to the LHS. That means 40 will be assigned to the LHS. And in either case, we get the larger of 2 numbers. Okay. So if you want to generalize that, we can use a scanf statement to get 2 numbers from the user. Ampersand X and ampersand Y. Now even if you are initializing with X is equal to 30 and Y is equal to 40, since scanf statement is appearing after that, the new value entered by the user will be overwriting the value 30 in X, and the new value entered by user will be overwriting the value stored in Y, which is 40. Okay. So this, after this statement, 30 and 40 will be overwritten by the new value entered by the user. Okay. Now this program, it is using doing some useful work, like you enter 2 numbers, it will print the larger value. Any 2 numbers, integers, it will compute the larger of the 2. Okay. Either first one is larger you are entering, or second one larger you are entering as larger. In both cases, the result will be the larger of the 2. Clear? Conditional operator, how it is working. This is having same effect as doing this. I'll modify it as X, A or B. Now I can do some other operation also. It need not be an expression, simple expression. It can be a compound expression, X minus Y. Here, if the first number is larger, it will add. The numbers will be added. If the second number is larger, the numbers will be subtracted, and the result will be. So result is subtracted since the second number is larger. 45 minus 67. Otherwise this will be added. Okay. So I used it for finding the larger of 2 numbers. What if I want to find the absolute value or absolute value of the difference? Absolute value of the difference, or absolute value of a number, absolute value of a signed number. Can anyone tell me how can I use this to find this conditional operator to find the absolute value of a given number? Let's remove this and try to develop. Use it for finding the absolute value of a given number. Absolute value of minus 3 is what? Absolute value of minus 3. What is absolute value? What is absolute value? Plus 3. So for any negative number, say minus 5, minus 7, the absolute value will be 7. Minus 7, it will be 7. Minus 5, it will be 5. For a positive number, absolute value will be the same number itself. 5 absolute value is 5. 7 absolute value is 7. Now I want to use conditional operator to find the absolute value of any input number. Any input number. So I can scan a input, say I can scan a number, single number from the user, and finally I should get the absolute value of that number as the result. So X is the number. I check X less than 0. That is my condition. And if that is true, what will I do? X equal to, how do you find the absolute value? X into minus 1. X is equal to X into minus 1. That means if this is true, that means X is a negative number. We are considering only integers. X less than 0 means it's a negative number. And if that is true, in the true part of the or the expression 2, we have to multiply the number with minus 1. Else, the same number itself is the absolute value. Else means X is not a negative number. X less than 0 is false. Understood? If X less than 0 is true, that means if X is negative number, we multiply it with minus 1. Okay, since it is stored in Z, I don't need to do X is equal to X into minus 1. I can directly do this. X into minus 1. Otherwise, simply give X. Let's see if it works. So I enter minus 5. The result is 5. I enter positive value. So I get the absolute value of a given integer using the conditional operator. So now you know how to find the absolute value. First you learned how to find the largest of two numbers using conditional operator. Then absolute value of two numbers using conditional operator. Clear? Okay. Any questions so far? Little bit confusing operators we have seen today. So next set of operators are called bitwise operators. Slightly different, or we don't commonly use these operators, not like arithmetic operators or logical AND operators. Bitwise operators, they act on individual bits in a number. Bits are any number, any integer, any data is made of bits, ones and zeros. They are called bits. And bitwise operators act on the bit level. In the bit level, they are going to work. Okay. There are 6 bitwise operators. Probably you need to learn at least 5 or even 6 also, not different. Shift left operator, shift right operator, bitwise AND operator, bitwise OR operator, bitwise exclusive OR, bitwise complement. Okay. We will cover probably in the next class. Okay. So, any doubt regarding any topics we covered today? We started with assignment operators, shorthand assignment operators, then increment and decrement operators, pre-increment, pre-decrement, similarly post-increment, post-decrement, and I explained the difference between pre-increment and post-increment whenever there is an expression LHS in the form LHS equal to RHS, that I explained. Then we studied the conditional operator. It is a special operator, ternary operator. 3 operands are there, and 2 applications we have found: finding the largest of two numbers, two distinct numbers, and also finding the absolute value of a given number, given signed integer value.